So we've talked about dissolving a substance into, in most cases, a liquid. Well, now we're going to talk about what happens specifically when you put an ionic compound into water and it separates into its ions if it's soluble. Well, let's say we have the salt sodium chloride. Everybody knows the formula for sodium chloride is NaCl. Well, when you dissolve it in water, it separates into the ions of sodium and chloride. And it does this in a 1-to-1 ratio. And the reason I know it's a 1-to-1 ratio is because over here in the formula, we don't have any subscripts. And so we always just assume that they're 1, which means that for each sodium chloride, I am going to get 1 sodium and 1 chloride. Well, what would we do if we had some subscripts in the formula? So let's say we had potassium sulfate. And potassium sulfate has the formula of K2SO4. Well, this is going to dissolve or ionize into 2 potassium ions and 1 sulfate ion. And the reason that it does this is because the subscript on the potassium is 2 and the subscript on the sulfate, there isn't 1, so it's just 1. Remember, this 4 is a part of the whole sulfate ion, not a subscript saying that we have 4 sulfates. And so if we were to say, well, how many moles of ions are these guys going to make? Well, this one is going to make 1 mole of sodium and 1 mole of chloride for a total of 2 moles of ions. Whereas this guy down here, the potassium sulfate, is going to make 2 moles of potassium, 1 mole of sulfate for a total of 3 moles of ions. And you can use these the same way that you use mole ratios in other equations, like to do stoichiometry and stuff.